All right, welcome back. Now we're going to consider what is referred to as GloVe. Okay, so previously we have seen the word to vec, and then we have seen the TF-IDF. We have also seen bag of words. All right, so now we're going to consider the last technique that we use when it comes to word embeddings. Okay, so GloVe stands for global vectors. Okay, stands for global vectors. Now let's see why we still need GloVe, because we have already discussed about word to vec, and we said that it's a quite robust method or technique which we can use to generate word embeddings. And now we are also talking about GloVe. All right, so let's see the problem that is existing with regards to word to vec. Okay, so if you remember, when we're doing the word to vec, we said that word to vec would take, for instance, it will take a sentence like this, right? A sentence like this. Then it will try to localize it by taking a context word, okay, and then the word surrounding it, right? Using the word surrounding it to predict the focus word, okay, to predict the focus word, or using the focus word to predict the entire context or the words surrounding it, okay. So that is if you're using whether CBOL, that is continuous bag of words, or you're using skipgram. Okay, so if you're using CBOL, then you base on the context to predict the focus word. But if you're using skipgram, then you base on the focus word to predict the entire context. That's the context words. Okay. Now, what happens is that in word to vec, we're always concerned about the local words that are surrounding the word. Okay, not the entire corpus. Okay, we don't take the entire corpus into consideration. All right, we don't take the entire corpus into consideration. Now, there's another old technique over there which we refer to as latent semantic analysis, LSA. Okay, look, latent semantic analysis. That one also uses only global statistics. That is, it uses only global context. Okay, only global contextual word, but it also ignores the localized words that are surrounding the particular word. Okay, so if you want to see cat and then predict some of the words that are likely to come when the word cat appears, okay, it's actually considered in the global statistics, but does not concern itself with words that are very, very close to the word cat. Okay, if you take the word, say, royal, okay, the word royal, the words that are very, very closest to royal will be something like queen and then king, right, something like that. Okay, but if you take this kind of technique, which is latent semantic analysis, right, it's going to take the entire corpus, meaning that words like, say, man, right, man, woman, right, something like that, are going to be very much related to royal, okay, because queen is related to royal, king is related to royal, and man is related to this, right. Man is related to king, and then woman is related to queen. So it's possible that if you pick a word like royal, right, it's going to have much relation with man and then woman, okay, something like that. Okay, so all of these tools have their own advantages and disadvantages. Okay, they have their advantages and disadvantages. For instance, word to vec captures local statistics, right, which is actually very good for analogy tags. Okay, when I'm talking about analogy tags, we are talking about the fact that you can have, say, man, right, man related to, say, woman. Okay, and the distance between them is very close, right, as compared to maybe something like maybe house. Okay, house would be far from, say, man and then woman, right. That is analogy, finding analogous, okay, something that are similar to each other, right. So if you use techniques like word to vec, you are likely to be able to perform analogous tasks very, very efficiently, right. However, if you take methods like, say, LSA, right, which is latent semantic analysis, which uses only global statistics, right, it does not actually do well when it comes to analogy tags, okay, because if you are relating royal to man, okay, although there is some kind of relationship over there, but the fact that the person is man does not mean that the person can become a king, okay, so that the person will be royal, okay. So it does not do very well when it comes to analogy tags, all right. And in the same way, word to vec is also limited, right? It's limited because it's actually finding the words that are very, very close. For instance, it is going to relate royal to, say, queen and then king, right? But it will not relate royal to, say, man and then woman, right? But it's also possible that the man can become a king, right? It's possible. And then a woman can become a queen. Okay, so there's kind of limitations over there as well, right? Now, the solution here is the GloVe. Okay, the solution here is the GloVe embeddings. What GloVe actually do is that it approach these two, right? It actually takes into consideration the technique that LSA and then Word2Vec uses. Okay, remember LSA will use global statistics, right? Whilst Word2Vec will also use local contextual based learning or local statistics. Okay, so this GloVe here try to be intersection of them, taking all of them into consideration. Okay, so rather than using a window to define local context, that is Word2Vec will use a window, maybe 2 words after the word, so maybe cat, okay, 2 words after it, 2 words before it, something like that, and then based on those 2 words to predict the cat, right, and based on the 2 words after it to predict the cat. So instead of limiting itself to that, right, what GloVe does is that it constructs an explicit word context, right, or what we refer to as cocherence metrics, right, using statistics across the whole text, right, or the whole text corpus. So this GloVe here is going to take care of or take into consideration the entire corpus, your entire data set. Whilst if you take Word2Vec, it's just going to take only that particular sentence and then pick only two or three words that come before it or after it to predict the word. But GloVe will take the entire text into consideration. So that's why we refer to it as global vectors. Okay, and then Word2Vec will be local vectors or local contextual based learning. Okay. Now with this one, you can drive semantic relationships between words, right, from the cocherence metrics. So for instance, if you have a large corpus, right, the word solid is more likely to co-occur, right, with ice than say steam. Okay, so if you go through the entire text, right, so maybe you have a large corpus, okay, a large text over there, right? Now, if you go through that large text that you have, it's likely that there will be much sentences where solid and ice actually appear together, right? Whether one appears after the other or one appears before the other, okay? It's more likely than say solid and then steam, okay? Than say solid and steam. It's also possible, right, that gas will also co-occur more often with steam, right, than say ice, okay? It's possible that there will be more sentences where gas and steam appears together, right, than say gas and ice. All right, so in that case, if you take the entire corpus, right, that's the global, you generate global vectors, it's possible to have these kind of relationships, okay? And that's what global vectors does, or GloVe does, okay? So that's basically the idea or the intuition behind GloVe. It tries to set the context between the global and then also the local vectors. All right, so we're going to go to the lab session and then we see the implementation of these things, okay?